Welcome to the workshop here at Waterbury. My name is Marty, and this is the next video about how I'm making a stainless steel Oona spout. So, I got some castings from the foundry. Look at that. These are the backplates that I had been working on, and these are the cylinder sections that fit into them to make up the spout. And so the next step here in the process is to make a fixture to hold this so that I can get some machining done on the back. So with that, let me change up the camera angle a little bit, and we'll do a little show and tell. Okay, so like I mentioned, I've got two parts here. They're going to be, one gets put into the cylinder, gets put into the back plate, it gets welded, and there's machining work to be done. And I need what I called was a fixture to hold this, because you can't quite just put it onto the table of a drill press, hope to hold it and then drill the parts, right? It's not going to work. You get lousy parts, and it's dangerous. So I've got fixtures that do that for me. Let me show you what the one I have currently for the Oona spout looks like. This is essentially it is a piece of round tube, flat plate, and stuff on it. And what I end up doing is I put the spout onto it like that. I got a little thing there that clamps it, and I got some clamps here that I can just tighten down, right, and that holds it in place. And sort of the way this works is I've got two pins essentially that the round part is pushed into. And so now I've got 3-point contact. I know exactly where the center of that part is. That's basic geometry. Anyhow, this is a fixture, what I'm calling a fixture, to machine this part. And granted, the operations on this part in particular are fairly simple. I've got to drill and tap 2 holes, and also I'm boring a hole in the middle. There's a boring operation. Boring operation? Well, it's not really a boring operation. Think of it like drilling, okay? But it just uses a different tool, a different process. So I'm creating a large hole with very smooth and accurately machined edges, okay? Anyhow, all the forces on this push the part down. It's really not set up for any milling. Milling creates other forces that'll shift this around, and once in a while I do have to do that. But this whole setup is dodgy. It's this clamp that makes it that way. But I don't really need it for this part. Anyway, I can't use this for the stainless steel Oona spout for that reason as well as another. The reason this works so well is because, or works at all for that matter, is that there is a decorative edge here around the border. And this edge creates a horizontal plane, right? And once I put that part down onto the hole, the horizontal plane created by that little decorative edge matches the horizontal plane created by the top of this metal piece, right? And so I'm able to just align the part. On this stainless steel version of the spout, that's not going to happen. There is no edge. So when this gets put down onto that hole, it wobbles. And in fact, it acts like a round ball or a hemisphere would when it's put into a hole. It'll move around. So I can't use this technique. I've got to come up with something else, and I have. So let me grab this and show you what I've got in mind. So one way of doing this obviously is just to kind of put this down onto the metal plate, clamp it somehow, and then just go ahead and do the milling and drilling, right? It's no big deal. Well, it is kind of, because I can't accurately put this down on just this flat piece of metal. I've got to locate it every time if I want the holes to be in the same place every time. If I don't, well, then I've got to measure it and figure out where they are, and it's a pain in the butt. I'd rather just figure something out now that puts this part into the same place, in the same orientation every time, and just take advantage of that in the future. So, I can't just clamp it down. And the other thing about that is, this part is a thin shell. And as such, it behaves like a bell, right? So it vibrates a lot, and that's really noticeable in this one, right? Hear that? It's like a bell. Bells are made of bronze. Anyway, this is a stainless steel bell, and if I just am not careful, it'll vibrate and create problems in the machining. So I can't do that. The best thing to do is support it here along the edge, where all the machining is happening, and yeah. Okay, so first thing is locate it. And what I'm going to do is I'm going to take advantage of this round hole, right? I can create something like that. I can put that on the plate, and now I can locate this on the plate in sort of the exact same position every time. Granted, it can still rotate, but I can take care of that. There's a simple solution to that. So part of the problem is solved. The other is, this is really not the best solution because I haven't supported the edge, right? And so it'll ring. So what I'm going to do is sort of change this up a little bit, and now I'm going to use this edge to support the part, and I'm going to use this, again, this round piece to align with the center. So now, essentially, if I bolt this down, I've got the part located. Granted, it can still rotate, right? But again, I said I can fix that rotation problem. So this is kind of the idea. Now, granted, this won't be out of plastic. It'll have to be steel or something more durable. And this flange will be wider to match that, and et cetera, et cetera. And I've got a design in mind. But before I show you that, I think I'll show you the solution to the rotation problem while I'm at it. So this is called an ID clamp. And what it is a large cylinder with slots in it. You can see slots, and there's a hole in the center. In the center hole, there's a screw with a tapered head. And I think you know what's going to happen, right? If you put that tapered head bolt in there and you cinch it down and push it, this is going to expand. And so that expansion will grab whatever's around it and prevent it from rotating. So I need to machine this down to the right size to fit this, and I'll do that later. But yeah, that's how I'm going to make this fixture. So with that, the next step I think is to show you the design, and I can't quite do that. Well, I can do that. It's on the computer. We'll go take a look at how that all works. So with that, let's go take a look at the design. Okay, so this is what the fixture is going to look like. Yeah. Anyway, so let's start with the pieces. This first piece aligns the casting at the right angle. It grabs onto the little tab on the back of the casting and puts it in the right place. And this thing, next one, is essentially a giant nut that forces the casting down onto the holder. Below that is the casting, which is this part, and all that sits on top of this block that gets machined in this shape. Just call it the holder. And inside of that is the ID clamp, and ID, by the way, it means interior diameter. So that cylinder section, like I said, expands and it clinches onto that hole in the casting and prevents it from rotating. And all that stuff sits on this square base plate. You can see a bunch of holes in there, and those are for bolts and studs to hold the rest of it, like what you see here, on top of it. So this would be the empty fixture. So this would get placed on top of the milling table, and then those two slots will hold two bolts, like so, and those, screwed down onto the milling table. And then the next step is to take the casting and flip it upside down and put it in there. And it's got a little tab. Anyway, so the next after that is to just take the giant nut, sort of put it on top, screw it down a couple turns just to loosely hold it. And then there's this doohickey thing that grabs onto that little tab. And that's just there to align the casting in the right place every time. And then to tighten down the nut completely, and then take a hex driver and tighten down that bolt for the ID clamp. Then remove that doohickey slider thing, and then just to give us more room, and then you're ready to mill. Okay, with that, I hope you get an idea of what I have in mind. And I got some material here. This will be the giant nut. This is going to be the holder piece. Then here's another smaller piece of steel. That'll be the little doohickey flange. Well, whatever. Any rate, I got some machining to do. I got some hunks of steel to turn into other hunks of steel that'll hold this piece of stainless steel so we can make a nice spout. So that, thank you for watching, and we'll see you on the next video. Probably one about machining parts.